This is our ND1, this one. Now, what is this ND1? We said it's called what? Delta. It's called delta. That's what it's called. It is a change in the value of option. Your value of the option here is how much? How much have you calculated? The change in the value of the option, if there's a $1 change in the value of the underlying asset. So if this went to 101, if this went to 101, this option won't remain the same, it will change. The increase is 1, so it's basically 1 multiplied by 0.664. So should the share price go up by 1, this will go up by 0.6664. So what is the delta? The change in the value of the option arising from $1 change in the value of the underlying asset. So if the share price moves from 100 to 101, the value of the option will change by 0.6664, or $1 multiplied by 0.664. My question is, but why should we be troubled with the concept of the delta? Why should we trouble you this afternoon with the concept of the delta? Let's go to application. If you hold shares in the company, if you are an investor in a company, what are you worried about? If you are an investor in the company, what are you worried about?
The share price will fall.
Yes. When the share price drops, what would you want to do? Suppose the share price, you don't want to hold on those shares. You want to do what? To sell them. So what you can do is, you can actually write an option yourself. You can write an option and give it to Mr. P. But Mr. P can come to buy those shares from you when the price drops. Now, if you want to write an option, how many options should you write and give to Mr. P to come and buy those shares off you? For you to know how many options to write, the number of options, you must know the delta hedge. The delta hedge will give you the number of options that you must write, such that should the price drop, then you can sell those shares. Before we talk more about the application, let's look at a small computation here. An investor holds a number of shares and sells an option, it is an option writer, a number of call options in the proportion dictated by the delta, ensures a hedge portfolio. So the number of options that you must sell is, you take the number of shares that you have and divide by ND1. The number of options that you must write is given by number of shares that you hold divided by your ND1. So you've got 100 shares, then you divide by your ND1 to find how many options should be written. Alternatively, if you have already written call options, imagine that you have already written call options, meaning that you have given Mr. Piri options, come and buy shares from you. You need to have shares because I may come for those shares. Then a delta hedge can be constructed by buying shares. So how many shares should you have? The number of shares to hold is the number of call options you have written multiplied by the delta hedge. So this, when I tell people this, so the story has changed now from options to investments. I say, yes, we're now looking at investments here. So you can create a delta hedge as an investor. So that is the issue of a delta. So that is one Greek. Okay. What are the other Greeks? The other Greeks are the sensitivity to other factors in the Black-Scholes formula are denoted by other Greek letters. Now you've got the gamma. You've got the gamma. You've got the beta there, the rho, and the theta. So just like you must explain what a delta is, you must tell us what is a gamma. So let us go now. What is a gamma? Measures the rate of change of delta as the underlying asset's price changes. So we're saying that this ND1 is not constant. This ND1 is not a constant variable. No, it does change. When there's a change in the share price, this changes. So what is the rate of change? The other one is a vega here. What's a vega? Measures the change in option value caused by 1% change in the volatility. Now remember the volatility? The volatility is measured by standard deviation. So when the standard deviation changes, what happens to the value of the option? That change is what you call the vega. What of the rho? The sensitivity of the option value to changes in the risk-free rate of return. Changing this. What of the theta? The rate of decline or the rate of change in the value of the option arising or caused by the passage of time, the T. So this one is the T. That one is the R. And that one is your volatility with standard deviation. So the point is that the value of the option is likely to be affected by a number of variables. The value of the option is likely to be affected by a number of variables, which are used in the computation. And the variables that we're talking about here is the time, as the time reduces, the T, as the risk-free rate changes, as the volatility measured by V changes, the value of the option will change. So these are what we call the Greek letters. And the one which is significant for you is the delta. Because it can enable you create a what? A delta hedge. We can create a delta hedge. You want to create a delta hedge? There is a question here for you to create a delta hedge. Remember, the delta hedge is a number of shares. Number of shares that you have divided by your ND1. That's what it is. Okay. Please, this is our last activity for today. Read through this question. Look at the situation this investor is in and put yourself in the shoes of this investor and ask yourself, what would I have done? And look at the options being suggested. And then you're going to answer the question in terms of how many options are we going to use. Take your time, read through the question. That's the last exercise that we're doing. I know that you must be tired by now.
That the risk appetite that the particular managers or the shareholders are willing to take or they have.
Me, I'm asking about you now, but you, what would you do? There was a proposal that you must sell all the shares immediately. The other one says you must do nothing. The other one says, let's go and write an option. So I like the nature of the question because it forces you to see what investors go through. If you're a fund manager, but even if you are an investor as an individual, I mean, like now, if you hear that the investment that you are owning now, the values will come down, what would you do? So this is really a tricky one, isn't it? But the idea behind this was for you to set up a delta hedge. So all you need is ND1, but I have to find the D1, you're going to add another minus. Now this causes students a lot of discomfort. So once you find the D1, so if your D1, that you calculate is minus 0.4. So when you come here, you're going to say N into minus 0.4. That's what it means. Meaning that what you'll be looking for a 0.4 plus 0.4. So when you work out this question, find that the answer will come out as a minus, but that minus that you need to put it here. So it's minus, so it becomes a 0.4. So when you go to a table, we're simply looking for 0.4. That's all. Okay, now let's find the D1. Please take your calculators. You've got, let's go. Let's go, people. What is our PA? What is our PA?
340.
340. What is our PE?
350.
Okay. What is the T?
It is 2 months.
2 months. What is the risk-free?
4%.
4%. What is the standard deviation?
40%. 0.4.
People now you have become experts. Now we just end up at ND1. Just D1 and then D1. That's it. Please, can we use our expertise now to find the D1? Let's find the D1, please.
We have steals.
Let's find the D1. Let's find the D1. If in the other two questions you didn't participate, can you please participate here now? D1.
Check this guy. Nice or not?
If in the other questions you didn't participate, please can you participate and find the D1? If you are slow in the other ones, find the D1. And I've told you that the D1 is a minus. I've already given you a hint. D1, anyone with D1? Anyone with D1?
Mr. Perry, I found negative 0.0545.
0.0.
545.
Anyone? Second that.
I found 0.05.
So how will I write this one? 0.06.
Yes.
Minus, eh? It's minus, eh?
Minus 0.055. So it should be, mine is 0.06 if you write off.
Yes.
Yes.
Oh, that's very good. You got it right. You got it right. So you need to find now the n minus 0.06. So simply find then the n of 0.06. Let's go to our table and pick that 0.06. Can somebody pick from a table? What is it? 0.06. What is it?
0.0239.
0.0239. Now remember that your D1 has become a positive. You get it, time? Your D1 that we're working with has become a positive because it was minus 0.06. So we'll find a normal distribution of a positive number. You're finding a normal distribution of a positive number. So you still add your 0.5. So please add your 0.5 there.
Zero 0.5239.
239.
Okay. So how many shares and how many options should you write? How many options should you write? How many shares do we have? 200. So you divide by 0.5239. What do you have now?
$381,752.24.
381.
752.24.
752. These are sold in batches of 1,000. These are sold in batches of 1,000. These options. So you come here, you divide by 1,000 to find the number of contracts. So how many contracts are these?
381. Okay.
How many contracts? 382 contracts. 382 contracts.
Mr. P, do we always have to round up?
Do we have to?
Okay. You always have to round up.
Yeah, because you are looking at 381.7, eh? So if you go down, you have less.
So in a case, if it was like 381.4, would we round down or would we still go to 382?
Okay, but remember there's an underage, yeah? There's an underage. But that is mathematical. That is mathematical. No one will take a lot of trouble with you for that. The major part of this question was, do you know how to create a delta H? Do you know how to get the ND1? So people, this is the concept of a delta H. Yeah? I'm sure you have picked an idea there of what you're trying to do. So you need to write options so that you can get rid of these shares. And since it's an option, if it's in your favor, what do? You're going to exercise it. If it's not in your favor, what happens? You don't exercise it. Eh? So in this case, this is a put option. So you have a right to sell those shares. Eh? It's your right to sell. So from yesterday to today, we have covered a number of things. Right? So if you look at our schedule, when do we meet again? Look at that schedule I gave you.
Tomorrow 16.
Huh?
Tomorrow 16.
What does our schedule say?
It's Tuesday.
Tuesday, I thought so.
Tuesday, 18 hours.
Exactly. So if you've got some questions, please bring those questions up on Tuesday so I can deal with them. Otherwise, what I would want to do is, I want to throw in a question on cost of capital. I want to throw in a question on investment appraisal. I want to throw in a question on business valuations. So on those evenings, that's what I intend to do with you. I intend to throw in questions on those items so that I will practice a question on cost of capital, we practice a question investment appraisal, a question business valuation. Otherwise, we may go in the exam having forgotten what synergy is. Eh? So we need to remind you of what is synergy. We need to remind you what is APV. Eh? Maybe some of us have forgotten APV now. We need to remind you what is ungearing and regearing. So those are the items that we want to look at. Eh? Yeah.
Mr. Perry, just a request.
Yes, please.
Would you be kind enough to include bond valuation?
That's what I've said, that will be evaluation question.
Oh, okay.
We'll throw in evaluation question, investment appraisal, and cost of capital. So we'll throw a question for each one of those.
Okay, thank you.
All right, people.
Thank you, Mr. P.